Hello and welcome back to our series on statistics. We're coming to you from the downtown core amidst a busy intersection. And let's begin. This is presentation 6.1 part B, and the topic is the normal distribution and its applications. This is in your workbook and textbook chapter 6. You can follow along. Now the focus of this presentation will be about a 95% symmetric region about the mean of a population. And we're going to take the example of a population of statistics marks, mean of 72, standard deviation 8. We want a 95% confidence interval, or an interval about the mean within which 95% of the data will fall. And that's depicted here with the arrow. If 95% is in the middle, then there's 5% in the two tails. Divided by 2 gives us 2.5% in each tail. Now we're going to focus here on the left tail. This is the negative z-score. So we go to the normal table and we try to find an area or probability of 0.025, and it's right here. And that z-score is 1.96. So that becomes, we're going to call this a critical value. And converting that critical value to an x value, you can see it on the screen here. That critical value on the left is 56.3. And on the right it's 87.7, where we rounded to one decimal. And the symmetric region then about the mean within which 95% of the data will fall is given here. We go to one decimal beyond that of the data. Now we're going to do the same thing for 90%. And you see it coming on the screen here. 90% in the middle means 10% on the two tails, or 5% in each tail. And we go to the table and try to find 0.05. And we find it is here, but it's sandwiched between two values. And those two values are associated with minus 1.64 and minus 1.65. We've added another 0 here because 0.05 is halfway between here, so it's halfway between these two z values, or minus 1.645. They're coming on the screen here now. We're going to convert those to an x value. The left-hand limit of that interval is 58.8. The right-hand interval is 85.2. And so a symmetric region about the mean within which 95% of the data will fall is given there. And we're going to do the same for 99%. And you can follow along. Pause the screen at any time. We're looking at 0.005, and we can see it's over here between minus 2.57 and 2.58, and again it's halfway between, so the z-score is minus 2.575, minus and plus. Converting those to an x value then gives us a left-hand endpoint 51.4, right-hand endpoint 92.6. And then this gives us an interval within which 95% of the data will fall. Now we're going to put this together. We have here the stochastic blood pressure for a group of children. It's known to be normally distributed with a mean of 128.8, standard deviation 7.2. A 90% region is associated with a z-score minus plus 1.645. Converting that, we have a left-hand point of 117. And a right-hand endpoint of 140.6. Now repeating that for the 95% interval, our z-score is plus or minus 1.96. Coming on the screen here, our left-hand endpoint is 114.7, right-hand endpoint is 142.9, and then the symmetric region, well, we ask you to do this yourself. For 99%, compute this yourself on your own. The limits are 110.3 to 147.3. The symmetric region about the mean then is given on the screen there. And we want to talk about what is considered to be an unusual event, and we're saying that anything outside of 2 standard deviations is considered unusual or questionable. And that becomes our criteria for the rest of the course for the most part. And note, this is associated with 2 standard deviations, in fact 1.96 as a critical value. Now we're going to look at that as an application. We have here, this is a binomial probability model which we're going to approximate with the normal curve. The mean or expected value is 20, standard deviation is 4, and here's the distribution. Mean of 20, sigma 4. So the 60% region is associated with z equal to plus or minus 1, or 16 to 24. And so if we have 29 successes in 100 trials, we're saying, computing the z-score of 2.25, which is greater than 2 standard deviations. So this is a rare and unusual event, and we're going to find the probability of getting an x greater than or equal to 29, converting it to z is equal to 2.25, and you can see here, 2.25 over here, 98.76%. That's coming on the screen here. So the probability of getting a value to the right of that is 1 minus 9878, or 0.122. So this is considered to be a rare event because the probability of it happening in the 29 or greater, 1.22%. So this calls into question the validity of the claim, and it tends to refute the claim. Here we have considered to be an unusual event because it's out in the tail here. That brings to an end presentation 6.1b. We ask you to review it, take notes, and go to presentation 6.2.